Okay, let's dive into this. August 7th. I mean, it might just look like another random square on your calendar, right? But it's actually one of the absolute greatest dates in the history of math. Today, we're unpacking an explainer of how this one single calendar date literally changed the mathematics powering our entire modern world. Think about your daily routine for a second. What do your go-to music apps, your local weather forecasts, and the GPS maps on your phone all have in common? Well, I know, it kind of sounds like a trick question, but the answer actually hides in the people connected to this one specific date, August 7th. Our journey today is a bit of a detective story. We are looking for the pattern inside the chaos. On this one date, across totally different centuries and completely different countries, brilliant minds were either born or passed away, and they left behind these incredible legacies that fundamentally changed the world we live in today. So, let's meet them, one by one. Let's start here. Have you ever wondered how insurance companies calculate risk for bizarre, completely unpredictable accidents? Like, say, the odds of a soldier getting kicked by a horse in the 19th century Prussian army. Yes, seriously, that is a real historical example. Well, the answer to that very specific, kind of crazy question goes back to August 7th, 1868. That's the birthday of a Russian mathematician named Ladislaus Bortkiewicz. He looked at all the random tragedies and the pure chaos of the world around him and decided he actually wanted to count them. And that led to his crowning achievement, the law of small numbers. By applying this concept called the Poisson distribution, he showed that incredibly rare events in massive populations actually follow a highly predictable pattern. He literally dug through the records of soldiers killed by horse kicks across, wait, let me make sure I have this right, 14 Army Corps over 20 years? And he proved that these random, unpredictable tragedies perfectly matched a strict mathematical formula. Because of him, we can predict the unpredictable in modern risk management. And this brilliantly illustrates a mind-bending truth about our reality. Even the most unpredictable accidents secretly follow a strict mathematical law. No matter how random things seem, the math is always there. Okay, we're still on August 7th, but now we jump exactly 1 year later to 1869. And moving across the globe from Russia to the United States, we find another absolute pioneer. Consider this for a moment. How do scientists actually track complex, continuous changes over time? Like, how do they map the exact trajectory of a massive hurricane or figure out how heat moves through a solid object? That brings us to Mary Winston Newson, born on August 7th, 1869. She was an absolute trailblazer who broke massive historical barriers. She traveled all the way to Germany to study under the legendary Felix Klein, ultimately becoming the very first American woman to receive a European PhD in mathematics. Talk about a game changer. Now, what's really interesting about this slide is her focus on differential equations and hypergeometric series. I know, those sound like incredibly dense academic terms, but in simple English, this is the mathematics that measures how things change. Whether we're tracking tomorrow's weather, mapping the orbit of a satellite, or engineering a massive suspension bridge, her research laid the foundation for how we understand complex systems that are in constant motion. She stepped right into this highly skeptical, male-dominated 19th century academic establishment and proved that genius knows absolutely no boundaries. She proved that anyone can master the mathematics of change. One date. So many incredible stories. Let's keep going. We are going to jump more than a century forward to another August 7th. This time we shift from births to a significant passing in the year 1985. Right at the dawn of our modern digital age. Have you ever wondered why your favorite music streaming app sounds so incredibly clear even when you're stuck on a really slow, spotty internet connection? Or how your home Wi-Fi manages to push so much complex data right through thin air? The answer to that very modern mystery actually goes back to a brilliant Hungarian mathematician named Gábor Szegő, who passed away on August 7th, 1985. Szegő worked with these highly abstract, complex concepts, things like Toeplitz matrices and orthogonal polynomials. But what does that mean for us in plain English? Basically, he created the mathematical tools that can break down messy, complex waves into simple, crystal-clear patterns called frequencies. His theoretical work from decades ago is quite literally the unseen engine inside your smartphone today. It's processing clear audio, compressing data, and managing those digital signals so you can listen to your favorite podcast without a hitch. It is such a stunning realization when you truly think about it. Every single song you have ever heard, every voice note you have ever sent to a friend, is secretly made of mathematics. It's just wild. Let's move along the timeline again. It's still the exact same date, but now we jump fully into the 21st century. Our final dot on the timeline takes us to August 7th, 2014, to explore what might just be the ultimate mathematical mystery. Here is the big question. Can we ever find stability and order inside systems that look like pure, unpredictable chaos? Imagine the swirling, violent currents of the deep ocean, or massive, turbulent weather systems rolling across the globe. Can that kind of chaos actually be tamed? This brings us to Dmitri Viktorovich Anosov, a brilliant Russian mathematician who died on August 7, 2014. He sought the answer to that exact question and ended up leading what mathematicians quite literally call a hyperbolic revolution. So the crucial point is his work on dynamical systems, specifically what are now famously known as Anosov systems. He proved that even when a system appears completely erratic and chaotic on the surface, there are hidden, unbreakable rules holding the whole shebang together. He helped us find structural stability inside the most complex, chaotic environments imaginable. His incredibly abstract work in dynamical systems leads us to this profoundly poetic realization about our universe. There is a beautiful, invisible structure hiding right in the middle of pure chaos. Let's move to our full timeline and see how this builds together. Look at this single thread: 1868, 1869, 1985, 2014. Every single one of these moments is tied directly to August 7th. Every single person we met in this explainer today, across different centuries, surviving wars, crossing borders, breaking massive barriers, they all asked the exact same question. What is the pattern hiding inside the chaos? And because these brilliant minds sought out those patterns, our world today has global GPS routing, crystal clear music streaming, complex risk prediction, and a much, much deeper understanding of the universe itself. You see, mathematics isn't just a bunch of numbers scribbled on a dusty chalkboard. It's the invisible architecture of our daily lives. So I'll leave you with this thought today. If mathematics can find perfect order in a random horse kick, a raging storm, a digital sound wave, and the swirling ocean, what beautiful pattern is hiding inside your chaos waiting to be discovered?